Hi everyone. We were doing problems based on the identities of trigonometry. We'll continue doing that. Today we'll be doing at least 3 videos more because we'll be segmenting them into different videos so that they don't get longer than required. I'm picking a few questions in the first video. So these are actually problems using identities, using identities, D-I-T-I-E-S, identities, using identities, problems using identities. Now, first question is sec square A plus cosec square A is equal to 10A plus cot A, and he says A is in first quadrant. A is in first quadrant. When you say A is in first quadrant, that means all ratios will be positive. All ratios will be positives. We have been given left hand side in terms of sec and cosec, and we want right in terms of tan and cot. So obviously we will use the identity. We know, sorry, I want to write it only in capitals so that you have no problem. We know that sec square A minus tan square A is equal to 1. This is one of the identities which we know. So we can write directly sec square A is equal to 1 plus tan square A. Similarly, we know cosec square A minus cot square A is equal to 1. Cosec square A plus cot square A is equal to 1. So it will imply cosec square A is equal to 1 plus cot square A. Sec square A minus tan square A is 1, so sec square A will be 1 plus tan square A. Cosec square A minus cot square A is 1, so cosec square A plus cot square A will be 1. Now we will replace sec square A and cosec square A with these terms. The terms will be 1 plus tan square A plus 1 plus cot square A. Now this will be equal to tan square A plus cot square A plus 2 plus 2. And how can I write along with 2? What I'll do is manipulation. As we told you that trigonometry is total manipulation. So what are we going to manipulate? And manipulation will come with practice. When you practice more manipulation you can do. Now what manipulation I will do? Tan square A plus cot square A plus 2 tan A into cot A. I have written along with 2, I have added 10a cot A because 10a and cot A are the reciprocals of each other. So in place of 10a, if I write 1 upon cot A will cancel. So you are changing nothing. You are changing nothing in the equation except you are manipulating. As we told you in the very beginning, that in trigonometry, a lot of manipulations will be there, and all those manipulations you will get only after doing practice. Now, why did I took 10a cot A? I took 10a cot A because they are reciprocals, and by using this, it will become a complete square. It will become 10a plus cot A whole square. 10a plus cot A whole square. A plus b whole square is a square plus b square plus 2ab. So 10a plus cot A whole square will become 10 square a plus cot square a plus 2 10a into cot A. And on taking out the square root, it will come out to be absolute values or modulus of, because we told you that whenever we take out the square root, it should come in terms of modulus value, absolute value. It is always positive. It is always positive, and since it's already been given that A is in the first quadrant, so whether 10A is there or cot A, they are going to be positive. So we can remove this and we can write simply 10A plus cot A, which was your right hand side. Which was your right hand side. We had to prove, if you look in the question, what did we have to prove? Under root sec square A plus cosec square A will be equal to 10A plus cot A. So we started with left hand side. Left hand side we used the basic identities of sec square A minus 10 square A is equal to 1. Cosec square A minus cot square A is equal to 1. And then we got the value of 10, we got under root 10 square A plus cot square A plus 2. Then at this stage we manipulated by adding 10a cot A with 2, because 10a into cot A will give you 1 only. 10a into cot A will give you 1 only. So when we got 10 square A plus cot square A plus 2 10a cot A, then it became what? 10a plus cot A whole square. And when we take out the square root, we told you we never get a negative sign. We always get a positive sign. We always get a positive sign. So that is why we found out the modulus of that. We found out the modulus or absolute value, and then we remove the modulus because we know in the first quadrant we said, because A is from first quadrant, so when you take out the square root, it will come out to be positive only. This was question number 1. Now let us see question number 2. What is question number 2? Is cosec A minus sin A. Cosec A minus sin A, sec A minus cos A, sec A minus cos A into 10A plus cot A is equal to 1. Now certain ideas you get from the question itself. As we told you, whenever we have to prove left hand side is equal to right hand side, we always take the more complicated side. Because I'm not going to start this question from the right, which has got only one digit 1. So what am I going to do with that? So we will start with left hand side, and from left hand side we'll achieve right hand side. Now if you see the first bracket, cosec and sine are the reciprocals. In the second bracket I have got sec A and cos A. They are also reciprocal of each other. And in the third, tan A and cot A, which are reciprocals of each other. So let us write Let's start with left hand side. Cosec A will be 1 upon sine A minus sine A. Sec A is 1 upon cos A minus cos A. In the third bracket I have 1 upon cot A plus cot A. It is plus only. Yes, it is plus cot A. Now what will it become if I take sin A as the LCM here? If I take sin A as LCM, I get 1 minus sin square A. If I get here cos A as the LCM, if I get cos A as LCM, then I will get 1 minus cos square A. And in the third bracket, if I take cot A as the LCM, if I take cot A as the LCM, I get 1 plus cot square A. Now, if you look at all this, 1 minus sine square A, 1 minus sine square A is cos square A. It is cos square A upon sine A. 1 minus cos square A is sine square A upon cos A. You know all these identities. These are basic identities. Cosec square theta minus cot square theta is 1. So 1 plus cot square A will be cosec square A. It will be cosec square A upon cot A. Cosec square A upon cot A. Now this sign, okay, let it be. Cos square A upon sin A into sin square A upon cos A into cosec square A. The cosec square A can become 1 upon sin square A. It will become 1 upon sin square A. And cot A is what? Cos A upon sin A. So it will remain cos A here and sin A will go up. So everything has been converted into cos A and sin A. Now we will have to just see how many things are there. Now let us see. This is cos square A. This is cos A, cos A. So cos A into cos A is cos square A. It will cancel with cos square A. Similarly here, sin square A, sin A is sin cube A, sin A and sin square A is sin cube A. So everything from numerator and denominator cancelled and you will get 1 as the answer, which is your right hand side. Which is your right hand side. So left hand side is equal to right hand side. Basically again we are using the most basic or fundamental identities. Fundamental identity. Cosec was changed into sine, sec was changed into cos, tan was changed into cot. Then we took LCM and again we applied the basic identities. 1 minus sine square A as cos square A, 1 minus cos square A as sine square A, 1 plus cot square A as cot A, and from that we got all the values. Now let us see the third question. What is the third question given to us? It is given sec to the power 4a minus sec square a is equal to 10 4a and plus 10 square a. I must say, all the things will come with practice only. As we told you in the beginning, that it will come with the practice. The more practice you will do, the more the better you will become at the subject. Mathematics, as it is all practice, and particularly this trigonometry is more of manipulation. Like on the left hand side, I can see sec 4. Left hand side is given in terms of sec a, and right hand side is in terms of 10a. So I have to convert sec in terms of 10. I have to convert sec in terms of 10. So what am I going to do? What am I going to do? I just convert sec square a in terms of 10 square a. So let us see left hand side. Left hand side is sec to the power 4a minus sec square a. I can take out sec square a common here. What to be left? Sec square a minus 1. Formula is we know what is the identity. Sec square a minus 10 square a is equal to 1. Sec square a minus 10 square a is equal to 1. So in place of sec square a, I can replace it with 1 plus 10 square a. And sec square a minus 1 can be written as 10 square a from the same identity. It's just question of taking one thing to the left side, one thing to the right hand side. So 1 plus 10 square a into 10 square a. And when we will multiply it, I'll get 10 square a plus 10 to the power 4a. So this is what right hand side was. So left hand side is equal to right hand side. Left hand side and right hand side are equal. So in all these three questions what we have done till now, you must have noticed that we only used the basic concept of the identities, and actually basically three identities. Sin square theta plus cos square theta is 1. Sec square theta minus tan square theta is 1. And also cosec square theta minus cot square theta is 1. Now next question is fourth one is 1 plus cot a plus tan a, 1 plus cot a plus tan a into sin a minus cos a into sin a minus cos a is equal to sec a upon cosec square a minus cosec a upon sec square a. So again, what are we going to do? We'll try and convert everything in terms of sin a and cos a. Let us try to convert everything in terms of sin a and cos a. Now let us start with left hand side. 1 plus cot a. So cos a upon sin a. Sorry. Plus tan a. Plus tan a means sin a upon cos a. We are starting with the left hand side. We always start with the more complicated side, generally with left hand side. And let it be sin a minus cos a. Let us see what can we get from here. If I will take sin a and cos a as the LCM, if I'll take sin a and cos A as the LCM, what will I get? I'll get sin A into cos A plus cos square A plus sin square A, and sin A minus cos A. Now if you see the numerator, if you see the numerator, complete numerator, not only the numerator in the first bracket but the complete numerator, a cube minus b cube is always equal to a minus b into a square plus ab plus b square. These are the basic uh, factorization which you have learned. A cube minus b cube will be a minus b into a square plus ab plus b square. A cube minus b cube will be equal to a minus b into a square plus ab plus b square. In place of a, I have sin a. In place of b, I have cos a. So sin a minus cos a into sin square a plus cos square a plus sin a cos a. If a is replaced by sin a and b is replaced by cos a, then I will get in the numerator sin cube a minus cos cube a and divided by sin a cos a. I mean, say in the beginning you can make a mistake as a student, that you will say, oh, I'm seeing here cos square a plus sin square a is 1 plus sin a cos a. There can be many more methods, but clearly there's certain thing visible. It is a minus b, a square plus b square, ab. So I'll convert into a cube minus b cube. I'll convert it in terms of a cube minus b cube. Now let us see next. Sin cube a upon sin a cos a. We are breaking up now the terms. Minus cos cube a upon sin a cos a. Is that clear? Now what are we going to do? Sin cube a will be divided by sin a. You will get sin square a upon cos a minus cos square a upon sin a. We have to look on the right hand side, that on right hand side what did we want? We wanted right hand side to be sec a upon cosec square a and cosec a upon sec square a. Now if you see this, if sin square a can be written as 1 upon cosec square a, 1 upon cos a can be written as sec a. You just reverse. 1 upon cos a is sec a, sin square a is 1 upon cosec square a. Because we want the answer in this format. We want the answer in this format. And cos square a will become sec square a, 1 upon sec square a, and 1 upon sin a will become cosec a. So now you get the answer in the form which you wanted, right hand side. In which you wanted right hand side. This is your right hand side. This is your fourth question. This is your fourth question. Now let us see the next question, fifth one. Fifth question is under root 1 minus cos a upon 1 plus cos a is equal to cosec a minus cot A. A is in first quadrant. A is in first quadrant. A is in first quadrant means again all ratios are positive. Whenever you see a thing like this, whenever you see a thing like under root, the first thing you comes to your mind is rationalization. You rationalize. You've been studying since standard 9th or maybe earlier than that, that how do we rationalize the numbers? Like it is 1 minus cos A upon 1 plus cos A. And so what I'm going to do is start with left hand side. It is 1 minus cos A upon 1 plus cos A into what I'll do is 1 minus cos A and 1 minus cos A. I multiplied the numerator as well as denominator by 1 minus cos A. You can rationalize both way. You can use 1 plus cos A also, 1 plus cos A also, because you are multiplying by 1. So, but why am I doing with 1 minus cos A? Because if I do 1 plus cos A, then in the numerator it will come 1 plus cos A whole square. And I see on the right hand side there is no denominator. So I don't want anything in denominator. 1 plus cos A whole square will give me 1 plus cos square A plus 2 cos A, which doesn't solve my purpose. But if I multiply it with 1 minus cos A, I am sure that 1 plus cos A into 1 minus cos A will give me 1 minus cos square A, and which will become sin square A. And when I'll take the under root, it will become sin A. And obviously then it will divide certain things. So in the numerator, I'll get 1 minus cos A whole square. And here I will get 1 minus cos square A. And you know that it is going to be positive. It is going to be positive. Whenever you take a square root, is going to be absolute value, but because they are in the first quadrant, I'm not putting the modulus there. It will become 1 minus cos A, because it is 1 minus cos A whole square. So when I take a square root will be removed. And 1 minus cos square A is sin square A. It will become sin A. It will become sin A. Because they are in the first quadrant, so they are going to come positive. And I have already, suppose I put it modulus, I can even put modulus, there is no problem. And later on I'll remove it. 1 minus cos A upon sin A, because they are going to be positive. Now I can break them as 1 upon sin A minus cos A upon sin A, because our answer is cosec A minus cot A. 1 upon sin A will become 1 upon sin A will become cosec A, and this will become cot A, which is right hand side, which is your right hand side. So by the application of the basic identities, we have been able to solve this out. My time is exceeding, so I'm saying bye bye just now for this video.